Today's lesson is just mixing yesterday's lesson and our knowledge of quadratics. And then we're going to do a little AP extension at the end of this lesson as well. Woohoo! So let's sketch the graph. Y is less than or equal to x squared plus 1, or x plus 1 squared minus 4 without a graphing calculator. Where do we start? Vertex. What is the vertex? Because this is in vertex form. -1 is the x. Remember, for the x, it's the opposite sign because it's x minus p squared, comma, -4. Q is usually plus q, so the q value here is -4. So let's plot that. Let's see. -1 to the left, down 4. There's our vertex. Next, what direction of the opening is this? It's going to be opening up. So that would be, opening is up. Oops. There you go. And our A value is, what's our A value? So what's the coefficient in front of the brackets if you don't see it? 1. So A is equal to 1. So what that means is we're just, from the vertex, we're going to graph just a regular x squared graph. Y equals x squared. Okay, so this is the graph y equals x squared, and we just shifted it to the left 1, down 4. That's all we did. So the next point, what we're going to do is 1 squared would be, so if I go 1 to the left, what's 1 squared? 1. So 1 to the left or right, and then we're going to go up 1. And then 2 to the right or 2 to the left, what's 2 squared? 4. So we're going to go 4 up from that point. 2 to the left, 4 up. Okay, 3 to the right, we're going to go up how much? 3 squared is 9. So 3 to the right from the vertex, we're going to go up 9. 4 plus 5 more is 9. 3 to the left, up 4, and 5 more is 9. Okay, because we have y is less than or equal to, is this going to be dashed or solid? Solid, and is it going to be above or below? Y is less than, we're going to do below. Okay, so let's draw a solid line through these points. And we're going to shade below. So think of where the vertex is, and we want to go below it. Did you bring your crayons? I should have brought crayons for you. That would have been fun. Hey? I actually have a whole bunch of crayons. Or highlighter works too. It feeds through the page. It's not as fun. Pencil crayons are fun too. No? So that's what my graph should look like. So what does that mean? Why do we shade? Just because it's fun? Yeah. To show all possible solutions, meaning that any point in the shaded area, how about on the line? Would that work too if it's on the line? Yes, because it's a solid line, any part on the line is also part of the solution. And right here, all the shading. Isn't it fun? Okay, so we could do a test point. Give me an example of a test point, a point we could choose as a test. We could use 0, 0. If we use 0, 0, what do we expect to happen? We expect it to be false, right? So you can use an unshaded portion if you want. So let's say if I use 0, 0, we expect to see false. So let's check that. I like 0, 0 because it's easier. 0 is 0 less than equal to 0 plus 1 squared minus 4. Well, that translates to 0 has to be less than or equal to negative 1 minus 4? Negative 3. Is 0 less than negative 3? No, that's false, and that's what we tested something in the false region. That's what we wanted to see, so we know our shading's correct. So you could also do a test in the opposite area and get the outcome you're looking for. In this case, we wanted it to be false. Does that make sense? A little backwards, but hey, if we can use 0, 0, that's always nice. It's a lot quicker. All right, so with that, are you ready to, oh no, let's do the next one together. You're done your coloring? I still hear coloring. What a good way to finish off the year. Okay, sketch the solution to y is greater than 2 times x minus 1 squared plus 3 without a graphing calculator. All right, where do we start? Vertex. Man, we have dealt with quadratics so much in the last 4 months. It's crazy. What is the vertex? 1 and 3. Good. The x is the opposite sign. 1 to the right, 3 up. Now, what's our a value here? 2. So it tells us a couple things. What does it tell us? We're opening up. So up, the direction is up. And when we square our y values, what are we going to do with them? Multiply it by 2. So normally the pattern is 1, 1, 2 is 4, right? 3 is 9. Now it's going to become 2 and 8 and 18, right, and so forth, okay? So when I move 1 to the right and I square it, I normally would go 1 up, but instead we're going to go 2 up, because 1 squared times 2 is 2. For the next point, I normally go 2 to the right and then 4 up, because 2 squared is 4, but now we're going to go 8 up. We're kind of actually off the page. No, we aren't. Yeah, we aren't kind of. We are off the page. We're off the graph. That's okay. Oh, dashed or solid? Because we have greater than, we want dashed. Greater than is dashed. There's no equal to underneath. And we want what direction if y is greater? Up, above the vertex. So where's your vertex? We want to shade above it. Right. Yay. Easy? Really similar to yesterday, except for we're dealing with quadratics. Okay. And the only other question I have for you then is, what do you want to use for your test point? Let's use 0, 0. And what do we expect? We want false. Okay, so 0 is 0 greater than 2 times 0 minus 3? No, minus 1 squared plus 3? That's better. 0 minus 1 is negative 1 squared. 1 times 2, 2 plus 3. 5 is 0 greater than 5. False. Hey, that's what we wanted. There you go. 1 page down. We're getting close. 2 more. That's it. Okay. Write an inequality given the graph. All right, what do we know about this graph? Okay, it has a negative. Yeah, we expect a to be less than 0. It's opening down. What else do we know? The vertex, what's the vertex at? Vertex is 3 and 2. Great. So where can we start with this graph? Do we know anything else? Yep. Ooh, how did you get a value of 1? Good. So you know it's going 1 squared is 1, and then when I go 2 to the left, it does 2 squared, which is down 4. Yeah, so our a value is 1. Now, if algebraically, you could also solve for your a value. Do you remember how to do that? If you didn't remember or figure out that you plug in some points. So we can plug in, so this is awesome. If you can figure out that right off the bat, your life is so much easier. So you're just saving yourself a whole bunch of algebraic work and chances for mistake. Oh, sorry, not 1. What is a going to actually be? -1, yeah. But if we wanted to solve algebraically for a, we have to plug in first our p and q. So x minus 3 squared plus 2. And then we're going to actually plug in what? A point. Do you remember this? It's a little final review for you right now. So we plug in a point. So give me a point. 1, 1. That's on the graph. 2, 1. Okay. So plug in 2 and 1. Y is 1 when x is 2. And then you could solve for your a value from there. 2 minus 1 is negative. 2 minus 3 is -1. Squaring it, just 1. So 1 is equal to a plus 2. Subtract 2 over, and we get -1. So you can solve algebraically for your a value if you didn't just figure it out. And then we can write our inequality. So is our shading going to be above or below in this case? Look at your vertex. Are we above your vertex or below your vertex? Below, so it's y is less than -x minus 3 squared plus 2. There's your answer. Now the example, oh yeah, let's just let you finish that. Okay, let's, for funsies, say, are we good? Are we done with this question? I'll wait for you to finish. Everyone got that down? Okay, so when we look at the next question for funsies, can you erase the y coordinates here? And pretend we don't know those at all. Okay? And what if I tell you that your y-intercept is 14? No, 10. Say y-intercept is 10. So I want to show you something a little new. Okay? So say you're given a quadratic, and here do we actually, if I erase the y legend, do we really know what the vertex is? Because the scale could be something we don't recognize, right? So what if I didn't know my vertex, but I do know, what do I know? Your x-intercept. So in the event, so if you don't know, if you come across a case, the vertex, but you know the x-intercepts. My writing is very bad today. There's something called factored form, and I don't think we've ever talked about factored form. Maybe we did. I'm not sure. But you can also write an equation of a quadratic in factored form, and it's exactly what it sounds like. So write the equation in factored form. We do know our x-intercepts too, right? 1 and 3, 1 and 5. Write the equation in factored form. So what is factored form? Factored form is this. Y equals A times x minus m and x minus n, where m and n are what? Your intercepts. M and n are x-intercepts. So that's factored form. Make sense? Sort of? Maybe? I don't know. Okay. Y equals A times x minus, what are my x-intercepts? No, m and n are your x-intercepts. Oh no, I did give you your y-intercept because I want to give you one extra point to find your a value. But if in the event you'll need to know the x-intercepts plus one other point to use this form, because you're going to have to plug in an x and y to find what a value is, right? So x minus 1 times x minus 5. How would you find your a value then? You need to plug in this case, the y-intercept, a point. So we know the point of the y-intercept. What is that point? 0 and 10. So let's plug that in. 10 is equal to a times 0 minus 1, 0 minus 5. Or negative 1 times negative 5. 0 minus 1 is negative 1. 0 minus 5 is negative 5. And what is negative 1 times negative 5? 5. So what's a? 2. And there you have your equation. So now that we have our equation, is y going to be greater or less than? So let's look at our graph again. It's below the vertex, so y is less than. And will it have the equal to symbol? Why? It's a solid line, so it will have the equal to symbol. There is our final answer. Okay? All right. One more page. So we're done the lesson for today. Let's look at the extension for fun. And then we're done. Woohoo! It's really quick and really not that bad. Okay? All right. Grab your graphing calculators. Oh, darn. Without the use. We're going to actually use both, without and with. Without the use of your graphing calculator, graph the following. Be careful how you number your grid papers so that both graphs fit. So don't just plug it in. We're going to get both equations first. How would I graph y is greater than or equal to x squared plus 2x minus 15? Well, I kind of tell you already. What are we going to do? Complete the square. Do you remember how to do that? Sort of. Okay, we factor out the a value of the first two terms. Do we need to do that in this case? No, the a value is 1. So we're just grouping the first two in this case. Remember that? Sort of, to make it bigger. Oops. Okay. What do we do from there? Divide 2 by 2 and then square it, and that equals, because we're making a perfect square, 1. So if I add 1, what else do I have to do? Subtract 1. Can I go straight to putting it outside the brackets? Yeah, our a value is 1, so it's no big deal. Go straight to putting it out. Okay, y is greater than or equal to, what does that become in factored form? X plus 2x plus 1. x plus 2 divided by 2 is 1. And then squared minus 16. So we need a y-intercept, or our vertex is going to be at what? -1 and 16. So our y scale needs to go up by how much? Oh, thank you, -16. Very, very important thing. Our y value has to, or y scale needs to go up by how much? 2. Okay, so back to this one. So we're going to go up by 2s. 2, 4, 6, 8, 10. In fact, I'm just going to go like this. I'm going to go 4, 8, 16, 20. Those are negatives. Can the x's go up by 1? Yeah. Let's make the x's go up just a regular scale of 1, 2, 3, 4, 5. So be very careful when we graph these. -1, -16 is our vertex. Now, our a value was what? 1. So from there, when we plot this, if I go 1 to the right, what are we doing now with that 1? We're going to square it. 1 squared is? Yeah? Oh, I did 2, 4, 6, 8. Oh my gosh. Nope, that's a 12. Thank you. Is that better? Yep. That's better. I can count. Okay, so let's try that again. Our a value is 1, so if I go 1 to the right, 1 squared is 1. So if I only want to go up 1, it's actually only half on here. Because our y scale is 2, our x scale is 1. And then 2 to the right, 2 squared is 4. So we're going to go up 4, which for the y, that's 2 of them. Agreed? Yeah, on the y's, exactly. And then 3 to the right, 3 squared is 9. 2, 4, 6, 8, 9. This is a fun one to graph. No? 4 squared is 16. So where are we intersecting? If I go up, right? Because 4 squared, 1, 2, 3, 4 to the right. I have to go up how much? 8. Something wrong here? Shoot. I think I messed up. No, I think I did. 1 squared is 1. 2 squared is 4. So right at the right? Yeah? Okay, let's do it again. 3 squared is 9. 2, 4, 6. Oh yeah, because 4 squared is 16. We're good. 2, 4, 6, 8, 9. And 9. And then where's my x-intercepts? Because we're going up to 16. Should get 3 and 1, 2, 3. -5. Good. Do you want to do one more? What's 5 squared? 25. Can I go up that high? Yeah? So 5 to the right, and then 25 up. So 16, 18, 20, 2, 4, 5 would make it at 9. So 4 and 9, and -6 and 9. Is this going to be dotted or solid? I think it's solid. I can't remember. Yay. I like solid. I'm biased. I have a solid line bias. So sue me. Okay. What's the other line? It was what? 2x, negative 2x minus 1. So when I plot that one, where do I start? Where do we? Negative 1. This is ugly, right? Because you're going to have half portions. Maybe I'll use green. I don't know. What's better? Blue, maybe? No, not blue. Green. Let's use green. Okay? Sort of. Maybe a darker green. Okay? So negative 1. So when I go up to, my slope is how much? What's my slope? It's equal to negative 2 or positive 2? Negative 2. So I'm going down 2. So that's on the y scale. That's like going down 1, right? And then right 1. So you're at down 2, right 1. Looks like that. Down 2, right 1. It's almost like 1 and 1. Because our y scale is 2. And then up. Okay. And then draw a line. You have to really be careful with this stuff. Now, oh, is it solid or dashed? Oh, good. Okay. So do you have something like that? Now we're not done because we have two inequalities and we want our solution to satisfy both inequalities. So for the quadratic, which way are we going to be shading? Above the vertex or below the vertex? Above the vertex. So bear with me. Don't do anything yet. Just watch, okay? Because I don't want you to make a mess of your sheet. So if I shade above the vertex, let's use yellow highlighter. It's all of this, right? Now, where is the solution for the line? Are we going above the line or below the line? Below the line, right? All of this. So where's our solution going to be? Isn't that cool? I love highlighters. Okay. So our solution is it has to satisfy both. Oops. Okay. Oh, it didn't come out as cool as it does on my screen. But it has to satisfy both. So where is the overlap of the shading? That's our solution. What color? The red. So that's the solution, is everything inside the red. Yes. We're just graphing the solution. So our solution is between these two. Like you would have to find their intersection point, and like in calculus, you would actually find the area between that and stuff. So if we are actually going to shade, our solution is going to just be in between. Because it has to be below the line but above the parabola. And the part that actually satisfies that is this portion here. Okay? And so that would be your solution. Any point within this, between their intersection points and then below the line above the parabola, any point within there is our solution for this two. If it says this is a system of inequalities, so it has to work for both of them because it's a system. So what would be an example of a solution? What point? Give me a point that would actually work. Negative 12, 0 and negative 12. 0 and negative 12. So I'm just going to zoom out for a second. Okay, so a test point would be, for example, 0 and negative 12 should work for both. And you have to check with both. So your graphing calculators can do this too. I'm just going to grab mine. Okay, when I go to y equals, remember that your graphing calculators can do shading. So view LCD. Okay, so one of the equations was y is greater than x squared plus 2x minus 15, and so we wanted greater. So stop me when I get to the greater, okay? Enter. Enter. I'm waiting. You're supposed to stop me. Okay, thank you. Okay, stop me when I get to the less than. Negative 2x minus 1. Oh, shoot. Okay, let's go back. So now this one's supposed to be less than. Thank you. Okay, so that would be the less than symbol. Graph that. And we want the overlap of the two. Oh, zoom 6. Window. What are our windows? Our windows were 0 to, or negative 10 to 10. It's big windows, eh? That was a big window. It was negative 20 to 20. Oh, shoot. Thank you. Good thing. I wish you guys are always around to, like, stop me. Okay, so we want the overlap. So you have one shading and then you have the other shading. So where the overlap is our solution. You can also do it backwards. So you can do something called reverse shading, especially if you're solving on a graphing calculator. It can get really messy. So if I want to do reverse shading, I'm going to do the opposite. And the white space is my solution. So instead of greater than, I'm going to do the less than on the first one. And instead of less, I'm going to do the greater. Okay? So if you want, you could also do reverse shading when you're doing a system of inequalities. And if I do reverse shading, the white space is my solution. So where it's not shaded is our answer. Okay? So that's something called reverse shading. All right. So if we check, we have to plug this point into our original. Everyone understands how to do that? Can we move on? Yeah. All right. Would you like to try this one on your own? Yeah. They're both linear. Come on. Just give it a shot. Oops. Good eye. Good eye. Good eye. Good eye. What's wrong? So y-intercept of 6. Yeah. Hey, not okay. Okay. -4. All right, there's 4 spots. The question is, 1, 2, 3, 4. Where are we shading? Only one of those gets shaded for this. Is it 1? Okay, let's check. Oh, let's use a highlighter. So if we're doing y for the first equation, y equals negative x plus 6, we want greater, so above. So you would have that. The second line is y is less than negative, so below the other line, right? Agreed? Oh, no, sorry, thank you. Ha! You were paying attention. Good. Okay. Y is greater than 2x minus 4. It's above. Yes, y is greater. Okay, so above, so the green portion here is our solution. So 1 is the answer. So actually, when you actually just shade, you just need to shade this portion here. That's our solution. Okay, just that intersection. Yeah, why? And so remember, if it's a negative line, we use our right arm, right? Above, below, above, below. Alrighty. Yay, we're all done.